Good morning students. In the previous session, we have discussed about the balancing the redox reaction by half reaction method. In this session, we are going to discuss about the balancing the redox reaction by oxidation number method. So, in order to balance the redox reaction by oxidation number method, let us consider one redox reaction. Let us consider the redox reaction. The dichromate is reacting with the sulfite ion. SO3 2- andre sulfite anta karitivi. Dichromate in the aqueous medium. AQ represents the aqueous medium. The given solvent has been dissolved in water. Therefore, this is known as aqueous anta karitivi. The dichromate is reacting with the sulfite ion, giving rise to chromium 3 ion plus sulfate ion. SO4 2- na navu sulfate ion anta karitivi. This is the one of the ionic reaction, unbalanced ionic reaction taking place in an acidic medium. We should balance this unbalanced redox reaction. The first step in order to balance this redox reaction is to write down the given reaction in an ionic form. Same as in the ionic method, that is half reaction method, the first step will be writing the given reaction in its ionic form. As we can observe here, the given reaction has been in the ionic form. First ionic form alide. Therefore, write down this reaction once again. Therefore, the first step in order to balance the redox reaction is writing down the given reaction in its ionic form. This will be the first step, that is writing down the given reaction in its ionic form. The next step of the reaction is, the next step in order to balance this redox reaction is finding out which species is undergoing oxidation and which species is undergoing reduction. In order to find out which species is undergoing oxidation and which species is undergoing reduction, first we should know the oxidation state of each and every species. So, let us find out the oxidation state of each species. So, we have find out the oxidation state of each and every species. The chromium oxidation state in dichromate is +6. You have already learnt about how to calculate the oxidation state. Therefore, I am writing directly the oxidation state of chromium in dichromate, that is +6. The oxidation state of sulfur in sulfite ion is +4, whereas oxidation state of chromium in +3 ion is +3 oxidation state, and the oxidation state of sulfur in sulfate ion is +6. This is about the oxidation state of chromium and sulfur in different oxidation states. Now, we shall move on to which species is undergoing oxidation and which species is undergoing reduction. You can observe here the chromium oxidation state is changing from +6 to +3. That means here the oxidation number is being decreasing. Oxidation number ಏನಾಗ್ತಾ ಇದೆ +6 ಇಂದ +3 ಹೋಗ್ತಾ ಇರೋದ್ರಿಂದ oxidation number decrease ಆಗ್ತಾ ಇದೆ. In terms of oxidation number, how can we define reduction? Reduction means decrease in oxidation number. Therefore, here the chromium is undergoing reduction. As there is a decrease in oxidation number, chromium is undergoing reduction. And you can observe the sulfur oxidation state is changing from +4 to +6. There is an increase in oxidation number. That means +4 ಇಂದ +6 ಹೋಗಿದೆ. Therefore, there is an increase in oxidation number. In terms of oxidation number, how can we define the oxidation? Oxidation means increase in the oxidation number. Therefore, here the sulfur is undergoing oxidation as there is an increase in oxidation number. This will be your second step of balancing the redox reaction. After finding which species is undergoing reduction and which species is undergoing oxidation, now let us move on to the third step of balancing the redox reaction, that is balancing the number of atoms other than oxygen and hydrogen. You can observe here on the reactant side chromium ಎಷ್ಟಿದೆ 2. There are 2 chromium atoms. When you observe in the product side, there is only one chromium atom. Therefore, the number of chromium atom has not been balanced. ಇಲ್ಲಿ 2 ಇದೆ, ಈ ಕಡೆ 1 ಇದೆ. ಹಾಗಾಗಿ chromium atoms balance ಆಗಿಲ್ಲ. In order to balance this chromium atom, what should I do? We should add 2 moles of chromium to this side. In order to balance the chromium atoms, I have added 2 in the product side. Therefore, next move on to the sulfur atom. Chromium ಆದ್ಮೇಲೆ next ಯಾವುದು ಇರೋದು? sulfur ಇರೋದು. Let us look into the sulfur atoms now. Here, there is one sulfur atom in the reactant side, and you can observe in the product side also there is only one sulfur atom. Therefore, it has been balanced. No need to balance the sulfur atom. By this end of the reaction, we have balanced the atoms other than oxygen and hydrogen atom. This will be your third step, that is the balancing of atoms other than oxygen and hydrogen atoms. Now, after balancing the atoms, we should balance the charge. In order to balance the charge, let us look into the oxidation and reduction reaction. You can observe here the chromium, the oxidation state of chromium is changing from +6 to +3. ಅಂದರೆ ರಿಡಕ್ಷನ್ ಆಗ್ತಾ ಇದೆ ಅಂತ ಹೇಳಿದೆ. ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ ಟ್ರಾನ್ಸ್ಫರ್, ಹೌ ವಿ ಕ್ಯಾನ್ ಡಿಫೈನ್ ರಿಡಕ್ಷನ್? ಗೇನ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ ಮೀನ್ಸ್ ರಿಡಕ್ಷನ್. +6 to +3 means 3 oxidation number decrease ಆಗಿದೆ. Therefore, the chromium has gained 3 electrons. Here, there is a gaining of 3 electrons. But you can observe that here there are 2 chromium atoms. One chromium illa, 2 chromium atoms. Therefore, the gaining of electrons will be 6. ಯಾಕೆ 3 electrons gain ಮಾಡ್ತೇವೆ. ಒಂದು chromium atom 3 electrons ನ gain ಮಾಡಿದ್ರೆ 2 chromium atom ಇದೆ. Therefore, the gaining of electrons will be 6 electrons. Similarly, you can observe the sulfur's oxidation state is changing from +4 to +6. Oxidation number increase ಆಗಿದೆ, oxidation ಆಗ್ತಾ ಇದೆ. In terms of electron transfer, how we can define the oxidation? Oxidation means loss of electron. ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ ಸಲ್ಫರ್ ಕಳ್ಕೊಂಡಿದೆ? ಯು ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ +4 to +6 ಅಂದರೆ 2 ಎಲೆಕ್ಟ್ರಾನ್ನ ಕಳ್ಕೊಂಡಿದೆ. ಇಟ್ ಹ್ಯಾಸ್ ಬೀನ್ ಲೂಸಿಂಗ್ 2 electrons. ದ ಸಲ್ಫರ್ ಈಸ್ ಲೂಸಿಂಗ್ 2 electrons. ಇಲ್ಲಿ ಒಂದೇ ಸಲ್ಫರ್ ಆಟಮ್ ಇರೋದು. therefore the sulfur is losing 2 electrons. You can observe here there is a gain of 6 electron. Chromium is gaining 6 electron, whereas sulfur is losing 2 electrons. As chromium is gaining 6 electron, but sulfur is giving only 2 electrons. In order to balance these electron, what we can do? We can multiply the sulfur. We can multiply the sulfur containing compound with 3. ಸಲ್ಫರ್ ಕಂಟೈನಿಂಗ್ ಕಾಂಪೌಂಡ್ನ 3 ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ ತಕ್ಷಣ ಏನಾಗುತ್ತೆ? ಎಷ್ಟು ಮೋಲ್ಸ್ ಆಫ್ ಸಲ್ಫರ್ ಇರುತ್ತೆ? ಫಸ್ಟ್ ಎಷ್ಟು ಮೋಲ್ ಇದೆ? 1 ಮೋಲ್ ಆಫ್ ಸಲ್ಫರ್ ಇದೆ. ಹಾಗಾಗಿ ಅದು 2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ನ ಕೊಡ್ತಾ ಇದೆ. ಅದೇ ನಾನು 3 ಮೋಲ್ಸ್ ಆಫ್ ಸಲ್ಫರ್ ತಗೊಂಡ ತಕ್ಷಣ ಏನಾಗುತ್ತೆ? 6 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ನ ಕೊಡುತ್ತೆ. therefore multiply the sulfur containing compounds by 3 in order to balance the number of electrons. So this will be your balanced redox reaction after balancing the number of atoms other than hydrogen and oxygen and balancing the number of charges. ಚಾರ್ಜು ಬ್ಯಾಲೆನ್ಸ್ ಆಗಿದೆ, ಇಲ್ಲಿ ಆಟಮ್ಸು ಬ್ಯಾಲೆನ್ಸ್ ಆಗಿದೆ ಅದರ್ ದೆನ್ ಆಕ್ಸಿಜನ್ ಆ್ಯಂಡ್ ಹೈಡ್ರೋಜನ್ ಆಟಮ್. ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್ ವಿಲ್ ಬಿ ಬ್ಯಾಲೆನ್ಸಿಂಗ್ ಯುವರ್ ಆಕ್ಸಿಜನ್ ಆಟಮ್ಸ್. ಈಗ ಇಷ್ಟು ಸ್ಟೆಪ್ಪಲ್ಲೂ ನಾವು ಚಾರ್ಜ್ನ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡಿದ್ವಿ, ಅದರ್ ಆಟಮ್ಸ್ನ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡಿದ್ವಿ. ದಿ ಲಾಸ್ಟ್ ಸ್ಟೆಪ್ ವಿಲ್ ಬಿ ದಿ ಬ್ಯಾಲೆನ್ಸಿಂಗ್ ಆಫ್ ಆಕ್ಸಿಜನ್ ಆಟಮ್ಸ್. ಯು ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ ದ ರಿಯಾಕ್ಟೆಂಟ್ ಸೈಡ್. Here, how many number of oxygen atoms has been present? You can see 7 oxygen, 3 3s are 9. 9 oxygen atoms plus 7 oxygen atoms, 16 oxygen atoms. Reactant side ಅಲ್ಲಿ ಎಷ್ಟು oxygen atoms ಇದೆ? 16 oxygen atoms ಇದೆ. Come to the product side, 3 4s are 12. 3 moles of sulfate ions ಇರೋದ್ರಿಂದ 3 4s are 12. 12 oxygen atoms ಇದೆ. ಈ ಕಡೆ 16 oxygen atoms ಇದೆ. The reactant side there are 16 oxygen atoms, whereas in the product side there are 12 oxygen atoms. ಎರಡನ್ನೂ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡೋಕ್ಕೆ ಇನ್ನೆಷ್ಟು ಆಕ್ಸಿಜನ್ ಆಟಮ್ ಬೇಕು? 12 ಇದೆ, ಇಲ್ಲಿ 16 ಇದೆ. We need another 4 oxygen atom in order to balance the oxygen atom. Therefore, in order to balance the oxygen atom, add water molecules. ಆಸ್ ಸೇಮ್ ಆಸ್ ಇನ್ ದಿ ಹಾಫ್ ರಿಯಾಕ್ಷನ್ ಮೆಥಡ್. ಇಲ್ಲೂ ನೀವು ಆಕ್ಸಿಜನ್ ಆಟಮ್ಸ್ನ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡೋಕ್ಕೆ ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ನ ಆ್ಯಡ್ ಮಾಡ್ತೀರಾ. ಎಷ್ಟು ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ನ ಆ್ಯಡ್ ಮಾಡ್ತೀರಾ? ಎಷ್ಟು ಡಿಫಿಷಿಯೆಂಟ್ ಇದೆ ಇಲ್ಲಿ? 4 oxygen atoms deficient ಇದೆ. Therefore, add 4 water molecules to the deficient side. In order to balance the number of oxygen atom, add water molecules to the oxygen deficient side. Therefore, I have added 4 water molecules. ಯಾಕೆ 4 water molecules add ಮಾಡಿದೆ? ರಿಯಾಕ್ಟೆಂಟ್ ಸೈಡಲ್ಲಿ 16 ಆಕ್ಸಿಜನ್ ಆಟಮ್ಸ್ ಇತ್ತು, ಪ್ರಾಡಕ್ಟ್ ಸೈಡಲ್ಲಿ 12 ಆಕ್ಸಿಜನ್ ಆಟಮ್ಸ್ ಇತ್ತು. ಡಿಫರೆನ್ಸ್ 4 ಇರೋದ್ರಿಂದ ಇಲ್ಲಿ 4 ಆಕ್ಸಿಜನ್ ಆಟಮ್ಸ್ ಡಿಫಿಷಿಯೆಂಟ್ ಇರೋದ್ರಿಂದ ಐ ಹ್ಯಾವ್ ಆ್ಯಡೆಡ್ 4 ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್. Here you can observe this redox reaction. Here the chromium is also has been balanced. ಸಲ್ಫರು ಕೂಡ ಬ್ಯಾಲೆನ್ಸ್ ಆಗಿದೆ, ಆಕ್ಸಿಜನ್ನು ಕೂಡ ಬ್ಯಾಲೆನ್ಸ್ ಆಗಿದೆ. ಬಟ್ ಹೈಡ್ರೋಜನ್ ಬ್ಯಾಲೆನ್ಸ್ ಆಗಿದೆಯಾ? ಇಲ್ಲ. ಈ ಕಡೆ 8 ಹೈಡ್ರೋಜನ್ ಇದೆ, ಈ ಕಡೆ 1 ಹೈಡ್ರೋಜನ್ ಇಲ್ಲ. The next step will be balancing your hydrogen atoms. In order to balance the hydrogen atoms, add hydrogen ions. ಎಷ್ಟು hydrogen ions ನ add ಮಾಡಬೇಕು? As many as hydrogen atoms present in the water molecules to the side which has been deficient in the hydrogen atoms. Therefore, add as many as hydrogen ions to the deficient side. ಎಷ್ಟು ಆ್ಯಡ್ ಮಾಡ್ತೀರಾ? ಎಷ್ಟು ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಅಲ್ಲಿ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ಸ್ ಇರುತ್ತೋ ಅಷ್ಟು ಆ್ಯಡ್ ಮಾಡ್ತೀರಾ. ಯು ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ ಹಿಯರ್ 4 2s are 8 hydrogen atoms ಇದೆ. Therefore, you should add 8 hydrogen ion to this side. Deficient sideಗೆ ನೀವು ಎಷ್ಟು ಹೈಡ್ರೋಜನ್ ಅಯಾನ್ಸ್ನ ಆ್ಯಡ್ ಮಾಡ್ತೀರಾ? 8 hydrogen ions na add ಮಾಡ್ತೀರಾ. After balancing the hydrogen atoms by adding the hydrogen ion, you can observe the whole equation is been balanced. ಹೆಂಗೆ? ಇಲ್ಲಿ ಕ್ರೋಮಿಯಂ 2 ಇದೆ ರಿಯಾಕ್ಟೆಂಟ್ ಸೈಡ್ ಅಲ್ಲಿ, ಇಲ್ಲಿ ಎಷ್ಟು ಕ್ರೋಮಿಯಂ ಇದೆ? 2 ಕ್ರೋಮಿಯಂ ಆಟಮ್ಸ್ ಇದೆ. ಇಲ್ಲಿ ಸಲ್ಫರ್ ಎಷ್ಟಿದೆ? 3 ಸಲ್ಫರ್ ಇದೆ. ಇಲ್ಲೂ ಎಷ್ಟು ಸಲ್ಫರ್ ಇದೆ? 3 ಸಲ್ಫರ್ ಇದೆ. ಆಕ್ಸಿಜನ್ ಆಟಮ್ಸ್ ಇಲ್ಲಿ 16 ಇದೆ. ಯು ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ ಹಿಯರ್ ಆಲ್ಸೋ 3 4s are 12, 12 plus 4, 16 oxygen atoms ಇದೆ. Next come to the hydrogen, 8 hydrogen, here also 8 hydrogen atoms ಇದೆ. Therefore, the final reaction, the final equation of the reaction is balanced redox reaction. This is how we are going to balance the redox reaction in the acidic medium by oxidation number method. It is same as the half reaction method. Half reaction method allu ನಾವು ಇದೇ ಸ್ಟೆಪ್ ನ ಫಾಲೋ ಮಾಡೋದು, ಬಟ್ ಅಲ್ಲಿ ಹಾಫ್ ರಿಯಾಕ್ಷನ್ಸ್, ಆಕ್ಸಿಡೇಷನ್ ಹಾಫ್ ರಿಯಾಕ್ಷನ್ ಮತ್ತೆ ರಿಡಕ್ಷನ್ ಹಾಫ್ ರಿಯಾಕ್ಷನ್ ಅಂತ ಸಪರೇಟ್ ಮಾಡ್ಕೋತೀವಿ. ಬಟ್ ಹಿಯರ್ we are going to carry out the balancing the redox reaction in the same step. Separate ಮಾಡ್ಕೊಳ್ದಲೆ ಒಂದೇ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ಕ್ಯಾರಿ ಔಟ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ. This is how to balance the redox reaction by oxidation number method in acidic medium. Now we shall move on to the balancing the redox reaction in basic medium by same oxidation number method. Now let us consider the second example. In this example, the redox reaction is taking place in a basic medium. We should balance this unbalanced redox reaction in a basic medium. The first step in order to balance this redox reaction is again writing the given reaction in an ionic form. ಏನು reaction ಕೊಟ್ಟಿರ್ತಾರೋ ಅದನ್ನು ionic form ಅಲ್ಲಿ ಬರ್ಕೋಬೇಕು. You have already know about this. Therefore, first step, write down the ionic reaction. So, after writing its ionic form, the next step will be the calculation of which species is undergoing oxidation and which species is undergoing reduction. In order to find out which species is undergoing oxidation and which species is undergoing reduction, we should know about the oxidation state of each species. So, let us calculate the oxidation state of each species. You can observe the oxidation state of manganese in permanganate ion is +7 and the oxidation state of bromine in bromide ion is -1 and oxidation state of manganese in manganese dioxide is +4 and the oxidation state of bromine in bromate ion is +5. After calculating the oxidation state, we shall find out which species is undergoing oxidation and which species is undergoing reduction. You can observe manganese changing its oxidation state from +7 to +4. +7 ಇಂದ +4 ಗೆ ಬರ್ತಾ ಇದೆ ಅಂದರೆ ಏನಾಗ್ತಾ ಇದೆ ಆಕ್ಸಿಡೇಷನ್ ನಂಬರ್? Oxidation number is decreasing. As the oxidation number has been decreasing, the reduction reaction is taking place. Therefore, the manganese is undergoing reduction. Similarly, when you observe the bromine, its oxidation state is changing from -1 to +5. Means there is an increase in oxidation number. As the oxidation number is increasing, the oxidation is taking place. Therefore, bromine is the species which is undergoing oxidation. Therefore, by calculating its oxidation state, we came to know that the manganese is the species which is undergoing reduction and bromine is the species which is undergoing oxidation. The second step of the procedure is over. After calculating which species is undergoing oxidation and which species is undergoing reduction, the next step will be balancing the atoms other than oxygen and hydrogen. So, look into the reaction. In the reactant side, manganese is 1. Onde one manganese ide. Product side also, the manganese is 1. Therefore, the manganese has been balanced. No need to balance these manganese atoms. And you can observe here, the bromine present in the reactant side is 1. And you can observe here on the product side also, the number of bromine atoms is 1. Therefore, the bromine atoms are also being balanced in this reaction. Therefore, no need to balance manganese or bromine atoms in the given reaction as itself has been balanced. After balancing the number of atoms, the next step will be balancing the charge. In order to balance the charge, let us look into the oxidation and reduction reaction. You can observe here, the manganese is changing its oxidation state from +7 to +4. +7 to +4 ಅಂದರೆ oxidation number decrease ಆಗಿದೆ. ಎಷ್ಟು oxidation number decrease ಆಗಿದೆ? 3 oxidation number decrease ಆಗಿದೆ. That means there is a gain of 3 electrons. As the reduction reaction taking place, there is a gain of 3 electrons. The manganese is gaining 3 electrons. And when you observe bromine, it is changing its oxidation state from -1 to +5. Oxidation number increase ಆಗಿದೆ. ಎಷ್ಟು increase ಆಗಿದೆ? 6 increase ಆಗಿದೆ. That means there is a loss of 6 electrons. That means there is a loss of 6 electrons. That is, the bromine is losing 6 electrons as it is undergoing oxidation reaction. You can observe the number of electrons during reduction 3, but the number of electrons during oxidation 6 electrons. That means the bromine is giving 6 electrons, but manganese is accepting only 3 electrons. Balance agidya illi charges? No. In order to balance the charges, what we should do? We should multiply the manganese containing compounds by 2. ಯಾಕೆ 2 ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಬೇಕು? The 1 mole of manganese is accepting 3 electrons. ಅದೇ 2 moles of manganese ಹಾಕಿದ್ರೆ ಎಷ್ಟಾಗುತ್ತೆ? 2 3s are 6. 6 electrons ನ accept ಮಾಡುತ್ತೆ. Therefore, multiply the manganese containing species by 2. After balancing the charges, the next step will be the balancing of oxygen atoms. So, in order to balance the oxygen atom, look into the number of oxygen atoms in the reactant side and the product side. You can observe in the reactant side the number of oxygen atoms, 2 4s are 8. 8 oxygen atoms. When you observe the product side, the number of oxygen atoms ಎಷ್ಟಿದೆ? 2 2s are 4 plus 3. 4 plus 3, 7 oxygen atoms. Whereas in the reactant side, how many number of oxygen atom? 8 oxygen atoms. Reactant side ಅಲ್ಲಿ 8 oxygen atoms ಇದೆ. ಅದೇ product side ಗೆ ಬಂದಾಗ 7 oxygen atoms ಇದೆ. Therefore, in the product side, there is a deficiency of 1 oxygen atom. Deficiency ನ ಹೆಂಗೆ ಇದು ಮಾಡೋದು? By adding 1 water molecule, we can solve this deficiency. ಯಾವ ಕಡೆ water molecule add ಮಾಡಬೇಕು? To the side which is deficient in oxygen atom. Therefore, add 1 mole of water molecule to this product side. So, in order to balance the number of oxygen atom, have been added 1 mole of water molecule to the product side. As in the product side there were 7 oxygen atoms, in the reactant side there were 8 oxygen atoms. There is a deficient of 1 oxygen atom, so we have added 1 mole of water molecule to the product side in order to balance the oxygen atom. After balancing the oxygen atom, we should balance number of hydrogen atoms. How we should balance number of hydrogen atoms? By adding hydrogen ions as many as number of hydrogen atoms present in the water molecule to the deficient side. ಯಾವುದು ಇಲ್ಲಿ ಡಿಫಿಷಿಯೆಂಟ್ ಸೈಡು? ರಿಯಾಕ್ಟೆಂಟ್ ಸೈಡ್. ಎಷ್ಟು ಹೈಡ್ರೋಜನ್ ಅಯಾನ್ ಆ್ಯಡ್ ಮಾಡಬೇಕು? ಯು ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ 2 hydrogen atoms present in the water molecule in 1 mole of water molecules. Therefore, add 2 hydrogen ions to the deficient side. So, after balancing the number of hydrogen atom, you can observe all the atoms has been balanced. But the redox reaction is taking place in a basic medium. So, we should add OH minus. This will be your last step when you are carrying out the balancing the redox reaction in basic medium. Ade acidic medium agidre, this is your last step. As we are carrying out the balancing the redox reaction in basic medium, add OH minus ion. ಎಷ್ಟು ಆ್ಯಡ್ ಮಾಡಬೇಕು? As many as hydrogen ions present, we should add as many as OH minus ions to both the sides. ಎರಡೂ ಸೈಡಿಗೆ ಎಷ್ಟು ಹೈಡ್ರೋಜನ್ ಅಯಾನ್ಸ್ ಇರುತ್ತೋ ಅಷ್ಟು OH minus ion ಆ್ಯಡ್ ಮಾಡಿ. ಸೊ ಆಫ್ಟರ್ ಆ್ಯಡಿಂಗ್ ದಿ OH minus ion, ಯು ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ 2H plus and 2 OH minus ಇದೆ. ಒಂದು H plus ಒಂದು OH minus ಕಂಬೈನ್ ಆಗಿ ಏನು ಫಾರ್ಮ್ ಆಗುತ್ತೆ? ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ದೇರ್ಫೋರ್ ದೇರ್ ಆರ್ 2 H plus ion and 2 OH minus ion. They will combine together to give a water molecule. After combining H plus and OH minus, we are getting 2 moles of water molecule. You can observe in the reactant side there are 2 moles of water molecules, whereas in the product side there is 1 mole of water molecule. As the water molecule itself present in both reactant and product, we can cancel one of the water molecule. Alva, illi 2 ide, illi 1 ide. 2 minus 1, 1 water molecule ಉಳ್ಕೊಳ್ಳುತ್ತೆ. ಅದನ್ನು ಯಾವ ಕಡೆಗೆ ಹಾಕಬೇಕು? ರಿಚ್ ಇರೋ ಸೈಡ್ಗೆ ತಾನೇ ಹಾಕಬೇಕು. After balancing the water molecule, this will be your last step which has been balanced. This reaction is balanced redox reaction. You can observe here, ಇಲ್ಲಿ 2 moles of manganese ಇದೆ, ಇಲ್ಲೂ 2 moles ಇದೆ. ಇಲ್ಲಿ 1 mole of bromine ಇದೆ, ಇಲ್ಲೂ ಒಂದೇ ಇದೆ. And oxygen atoms 2 4s are 8, 9 oxygen atoms ಇದೆ, ಇಲ್ಲುವೆ 2 2s are 4, 5 6 7 8 9 oxygen atoms ಇದೆ. Finally hydrogen, ಇಲ್ಲಿ 2 hydrogen ಇದೆ, ಇಲ್ಲೂ 2 hydrogen ಇದೆ. Therefore, the last step, the last reaction is your balanced redox reaction in basic medium by oxidation number method. Oxidation number method ಅಲ್ಲಿ ಅಸಿಡಿಕ್ ಮೀಡಿಯಮ್ಗೆ ಏನೇನು ಮಾಡಿದ್ರು ಬೇಸಿಕ್ ಮೀಡಿಯಮನ್ನು ಅದನ್ನೇ ಮಾಡ್ತೀರಿ. ಟಿಲ್ ದಿಸ್ ಸ್ಟೆಪ್ ಎಲ್ಲಿವರೆಗೂ ಹೈಡ್ರೋಜನ್ ಅಯಾನ್ನ ಆ್ಯಡ್ ಮಾಡ್ತಿರೋ ಅಲ್ಲಿವರೆಗೂ ಸೇಮ್ ಪ್ರೊಸೀಜರ್. ಬಟ್ ಆಫ್ಟರ್ ಆ್ಯಡಿಂಗ್ ಹೈಡ್ರೋಜನ್, ಆಸ್ ದ ರಿಯಾಕ್ಷನ್ ಈಸ್ ಕ್ಯಾರಿಂಗ್ ಔಟ್ ಇನ್ ಬೇಸಿಕ್ ಮೀಡಿಯಮ್, ವಿ ಶುಡ್ ಆ್ಯಡ್ OH minus ion. OH minus ion ಆ್ಯಡ್ ಮಾಡಿ ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ನ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡಿ ಬರೆಯೋದೇ ಲಾಸ್ಟ್ ಸ್ಟೆಪ್ಪು. ದಟ್ ಈಸ್ ಯುವರ್ ಬ್ಯಾಲೆನ್ಸ್ಡ್ ರೆಡಾಕ್ಸ್ ರಿಯಾಕ್ಷನ್. These are the 2 mediums in which the balancing the redox reaction will takes place, that is in acidic medium and basic medium in both the methods, that is oxidation number method as well as in half reaction method. This completes your redox reaction chapter, a very important chapter. Go through all the videos, that is how to calculate the oxidation number and how to balance the redox reaction.